All right, so here's the video for precision measurement. So I'll tell you this, at first it may seem very abstract, and this is probably mostly applicable to industries that require a very high degree of precision. But we also apply it to other industries, to more basic day-to-day industries, okay? Or examples, real life examples. So I think this is a very important concept to know, especially if you're going to be working in manufacturing or in a trade. You need to know these terms. So it's a short unit, but here it is. Okay, so do not round in this unit. Very important. It says it right at the front, obviously. So keep that in mind. So here, some definitions, some fill in the blanks. So follow me. Accuracy refers to how close a measurement is to its target value. To be accurate, a measured value must be as close to the real value as possible. Okay? If you claim to have measured something accurately, someone should be able to repeat the process and get the same value, right? So if you did something accurately, if you measured something to be 15 inches, then somebody else should be able to grab that measuring tape, measure it, and get the same value. That means that you're accurate. To be accurate, you should use a standard unit and an appropriate scale, right? So standard units, right? Centimeters, inches, kilometers, miles, anything, teaspoons, tablespoons, cups, right? Maybe add that cups, like if it's baking something, measuring, that is all standard. Those are units that would be recognized worldwide, right? Ounces, feet, and so forth. An appropriate scale, right? Actually, let's talk about non-standard units. So if you use like a body part, right? Your hand span, right? Your hand span like this, your feet, your steps. That would not be an accurate measurement. Why is that? Well, imagine me, right? I'm close to 6'5". My steps would be a lot bigger than someone else's step. So if I say, yeah, that the soccer field, I measured it, I did 65 steps. And do the same thing on the other side and then mark it, well, it wouldn't work, right? It's not the same distance. Or if somebody were to measure my 65 steps, again, you wouldn't be able to repeat the same measurement because we have different units, so to speak, right? So those are considered non-standard. They would not be accurate if you use them, okay? What's an appropriate scale? Well, you wouldn't be using miles to measure the length of your hair, right? Or your height. That would be, it could be done, but it would not be a good scale. It would not be very useful, right? Because if you rounded it to the nearest mile, the length of your hair would probably be 0 miles, right? Because it's compared to a mile, it's so small that you would have to round it because it would be 0.00 something miles, right? So if you rounded it to your nearest mile, you'd have 0 miles. So scale is also not, has to be appropriate. So you'd use centimeters or millimeters for that, right? So keep going. Accuracy can be affected by improper or careless use of the measuring device. So if you're not using it correctly, then like if measuring tape, if it's not nice flat, like if you're measuring something and the tape kind of does this along the board, right? If this is your tape and that's a little lip there that the measuring tapes all have, if it's like bending or not flat against, you're not using it properly, right? If you're not making sure that the piece of wood is exactly, against that little lip, you're not using it, and it's not accurate. That would be considered inaccurate. The other reason would be if you have a damaged or faulty measuring device. Okay? So it could either not have been manufactured properly or it's damaged. So damaged sometimes because of repeated use. Like let's say if you use a measuring cup and for whatever reason you leave it too close to the stove while you're cooking something else and it kind of gets too hot, it might mold or bend or something like that, and it's no longer accurate. Okay, so here are some examples, right? Here, when you're supposed to measure cups of flour, you're supposed to level off the top, right? So this would be inaccurate. This would be accurate. Okay, accurate, right? Proper use, right? And this would be inaccurate because you're not in improper, right? Not leveling off, right? Not leveled at the top. So that'd be an example there. So we would say, hey, which one is accurate? This one is because it's properly used, and both of them do not look damaged, right? So it's not the actual device used, it's the actual improper use, right? And then here you have a ruler that is nice and straight, and this one, I don't know if you can tell it, it's a little warped, right? Damaged ruler, right? That one right there is damaged versus this one is not damaged, right? Perfect. So this would be considered accurate. Anyways, moving on. I think you get the picture. So I'm not going to do every single example. So let's go to page 3. I will rather scan it, and if you're not sure about some of them, then you either look at the scanned version or you ask me on Monday. So state whether or not each scenario would result in an accurate measurement. Explain, making reference to the unit being used and the scale, right? So you want to talk about units and scale. If both of them get a check mark, you would conclude that the measurement would be accurate. So let's see here. We use centimeters to measure someone's height. Well, this is a standard unit. Check, right? And the height, would centimeters be appropriate to measure someone's height? Absolutely. Centimeters is an appropriate scale, right? So check. So you're making reference to the scale, making reference to the unit and the fact that it's standard centimeters. Everybody in the world knows what a centimeter is. So therefore, right, accurate. That'd be, if you use that to measure the height, you would say that's an accurate measurement. Somebody would be able to repeat that. Using your forearm to measure the length of a picnic table. The forearm, right, not standard, not standard. Actually, it fails right there, but the length of the picnic table, you would have to say scale is appropriate. It is actually an appropriate scale to use your forearm, right? It's actually reasonable to use that to measure the picnic table. It's not out of question, right? But this would be because, so this is check, but there's an X there, therefore not accurate. Okay, and so forth. So you can continue this practice with the rest and see what you get. Okay, maybe what I will do is I'll just show you on here if you just want to know, you don't want to bother with going to Google Classroom later, what the answers are for the rest. And this is not as pretty as it would have been on the lesson here because I just made a rough draft, but there it is. There's one more on the other page. Tablespoon is actually, teaspoon, tablespoon is standard, and to measure sugar, that's an appropriate scale, right? So that would be an accurate measurement as well. Maybe cover this up and read it. Mary used a measuring tape to determine the width of a wood piece. It was supposed to be 4 inches wide, yet she recorded 3 7/8 of an inch. So not quite what the target was. Why might this be? Explain. So in these types of questions, you're supposed to either mention the fact that she did not use it properly and be specific, as well as maybe the measuring tape was damaged, right? So this is what I have here. Option one, the measuring tape could have been faulty or damaged. So maybe the marks were scratched off and she couldn't quite read it well. Option two, she may not have ensured that the tape was straight and flat against the piece of wood that she was measuring. You could also say that she may not have been comfortable using an imperial measuring tape, so not familiar with fractions, right? So it could be a variety of reasons. Okay? So let's keep going. Okay. So precision and uncertainty. Okay. So here we go. Very important concept. This is basically where the math will start. Okay, precision refers to the smallest increment on a measuring device. Another way of saying this is that the precision is the smallest amount by which a measuring device can go up or down by. So here it is again. Precision is the smallest amount by which a measuring device can go up or down by. That's what precision is. Every measuring device, no matter how precise, will have a limitation. So it doesn't matter how precise that device is, it can measure like the width of a hair, of your hair, which is very, very thin, right? There's still a limitation that that device has. It can only go so close, and then there's some level of uncertainty, right? Precision essentially states what this limitation is. So I've kind of tried to explain precision in three ways here. Okay, probably worth adding to your study sheet. Uncertainty. Due to the fact that every measuring device has a certain limitation, there is always some uncertainty. Uncertain. The name kind of says that there's something that we're not sure about. Right? There's always some uncertainty. So you will have never done this before, but we will add that to every measurement moving forward. All measurements have the potential to be off, right? Measurements have the potential to be off, regardless of the precision of the measuring device. At some point, you have to round up or down. At some point, you have to. When you're measuring, quite often, right? You kind of mark off. This is, I think, where it is, but sometimes you do a little bit of rounding. It's not a whole lot, and it doesn't matter a whole lot when you're doing your own projects, but in industry, it does. So uncertainty is also called the margin of error, the amount that you can be off by. Same thing. Okay. The uncertainty is always half the precision. Uncertainty is always half the precision. That's very important. So if you know your precision, then just divide it by 2, right, to get your uncertainty. And usually we put a plus or minus in front of it. But this is very important. This right here you should have on your study sheet. That's why it's boxed in. Okay. You're expected to state precision and uncertainty in the following scenarios. Okay. The following scenarios. So here we go. I can either give you a picture or a diagram. I can just give you the actual measurement of something, and it could be stated in words. So you should be able to derive the precision in each of these cases. Okay, so let's go picture or diagram. Guys, this is the precision. In this case, every marking has a number. Okay, and you can clearly tell that from one marking to the other, you're going up by a certain amount. And in this case, it's quite easily identified as 10 millimeters, right? You're going up by 10 millimeters every single time. And that is what we call the precision in this unit, okay? That's how precise, that's the precision of this device. So we go the smallest increment is 10 milliliters, right? It's milliliters here. So precision would be 10 milliliters. And the uncertainty, remember, the uncertainty is half. So we go 10 divided by 2. So that's plus or minus 5 milliliters. The province is okay if you don't put the plus or minus when you're just stating the uncertainty. But that's normally what happens. Okay? So the precision is 10. The uncertainty is plus or minus 5. Right? So every time you take a measurement, we might be off by 5 milliliters. That's the standard way of doing it. Next, this one is a little trickier. Let's say you get an actual measurement. We have no idea what device has been used. So we are assuming that this is the precision of that device. This is as small as it can get. So here's what I want you to write down. No idea what device has been used. Unlike here, we did. Here we have no idea, right? We assume the precision based on value given. Okay, based on the value given. That's all we have. So let me write this again. So assume this was on the screen of the device. This was on the screen. This is what it ended up reading. It could have been that one up, had this piece or whatever was measured been a little bit bigger, it would have been 0.01 bigger, right? Or we could say that if it had been a little shorter, this device would have been able to do this, right? Gone down by 0.01 or up by 0.01. So this is where the precision lies. It lies on the second decimal of, this is how precise this device was. So the precision, we can say from one marking, let's say, to the other is 0.01, right? Plus 0.01, and then from here to here, it will be plus 0.01, okay? 1 second here, somebody's. All right, so where were we? The precision here, we almost made ourselves a device, right? And this is where it's at, right? 0.01, 0.01. So the precision is 0.01 of a centimeter. It's basically you put the 1, in this case, on the second decimal place, because this is where the limitation is of this device, on the second decimal, okay? So the uncertainty, watch this, you take that number and you divide it by 2, and that's 0.005. What are we at? Centimeters. Okay, and we usually put plus or minus in there. So there it is. That's how you do it when it's an actual measurement. Next is a ruler marked in half-inch increments. That is very important right there. Half-inch increments. Okay, so it's actually telling you the precision right there. So you can actually say half-inch increments, or you can turn that into a decimal. Right? It's up to you. Therefore, the uncertainty is half of half is a quarter of an inch, or right, you go 0.5 divided by 2, that's 0.25 of an inch. Right, so that'd be the precision and the uncertainty either as a decimal or fractions. You're allowed to keep them in either format. Okay. All right. So I'll do one more because there's a case where this is a little trickier. So follow me. So I see that it's already past 20. Try my best here, but I'm going to stop very shortly. Okay. So watch this one here. Not every marking has a number. So I'm going to tell you this. The precision I'm going to tell you is high minus low, make sure that's in brackets, divided by the number of gaps. Okay, high minus low divided by the number of gaps. So we go precision. What's high minus low? So I will tell you, in this case, I just grab two numbers that I see, high and low. So I focus on those. So it's 200 minus 100 divided by how many gaps are there between the two numbers? 1, 2, right? There are two gaps. That's how I count. 1, 2, two gaps. So I will divide it by 2. So 200 minus 100 is 100. Divided by 2 is 50 mLs. That's my precision right there of this. And you can check it, right? 150, 200. You could go back. This would be 50 and then 0, right? So you should be able to get that. So 50 divided by 2, that's for the uncertainty. That'd be plus or minus 25 milliliters. Okay, so that's how you do it for one like that. So I'll finish this and then you're off on your own. I'll tell you which ones to try. So in this case, the precision, the smallest, we're assuming that this device that has been used to measure this length is precise to the nearest inch. There are no decimals, so every inch will be 6 foot 3 inches, or it could go 6 feet 1 inch, right? That's what we're assuming. So it's going up by 1 inch at a time. So half of that would be plus or minus 0.5 of an inch. That's the uncertainty there. Measuring tape with markings of a quarter inch. Precision is a quarter inch. It's telling you, right? Or you can say 0.25 of an inch. So the uncertainty, half of 1/4 is actually 1/8. You double the denominator. Or you go, if you take that and divide it by 2, you get 0.125 of an inch. That's your uncertainty, and it should have plus or minus in front of it. Okay? And therefore, that's how you do it. Okay? All right, I'm going to let you do the rest. So I'll tell you up to what page you're going to work. So from 6 all the way to, I have lots of measurements there, all the way to 16. From 6 to 16, and you gotta, especially when it comes to this one here, question on page 7, because I'm already over and I don't want to, I'm going to ask you to find a precision and uncertainty for each one of these. But it's asking you this, watch, which one is more precise out of these? And the answer is the one with the smallest precision. So whichever precision is the smallest when you end up doing this, so you're going to have to go high minus low divided by gaps. That's the best way of doing this. And then you tell me which one is the most precise. So from 6 all the way to 16, I will scan it, upload it. Thank you very much. Have a good one.